Okay, just a quick kind of overview of this again. If it says simple interest, you're right here. In real life, we usually only use simple interest for things like, say, 1 month on a credit card. So if you have a balance of, $2,000, your interest rate is 22%, it'd be 0.22, but then it would be 1/12 because it's not 1 year, it's 1 month. So you'd use 1/12. That's about the only time we use simple interest, is on a month-to-month basis with things. Anything that is a chunk of money is going to be over here. Okay. So here, if you inherit a chunk of money and you invest it for the future, A is future value, money with interest in the future. If you have a goal that you're trying to save up with a chunk of money, so you need $20,000 in 5 years for a wedding, what chunk of money do you need to save up today? That's this one. So P is present value. So A is your money with interest that you want. You want to know what you need to invest today to get to that goal. Again, but a chunk of money. And then same thing down here. If you have a chunk of money, or a lump sum is what we call it, and you invest it where it gets interest every second, every millisecond, every 1,000th of a second, that's continuously compounding. That's this formula. And again, E is a key on your calculator. This one is yield, effective rate, yield, APR, APY, annual percentage rate, annual percentage yield. There's no money involved in this one because you're comparing apples to oranges. You're comparing like interest rate of 4.5 compounded daily to 4.6 compounded semi-annually. So you're just comparing interest rates. But otherwise, everything over here is a chunk of money, a lump sum. Like you invest $5,000 and you're done. You don't make payments, you don't add to it, you just let it sit there, okay? This side of the formula sheet is payments, okay? Now, I already made a video of this. This is if you're using a payment to do a house payment or a car payment. And again, notice there's a negative in there, exponent. And usually it's a good idea to maybe add another parenthesis around this guy, okay, just to be safe, okay? Because you want to get an answer to that before you divide here, okay? But I'm going to focus on these two up here. All right. This one is if you know your payment and you're saving up for retirement usually. It could be another big item, okay? Like maybe you own a business and you're saving up to buy some type of equipment and you're making a payment for, say, 20 years into account to save up for that big ticket item. But you're using a payment to save up for something in the future, okay? That's this guy. Again, A is always future value, money with interest, okay? The amount of money with interest. This is if you know you have a goal, like you want to save up, I don't know, $30,000 for a down payment on a house and you want to buy the house in 5 years, what payment do you need to make that happen? So here you know your payment and you're saving up for the future. This will give you your future value, money with interest. Here you have a goal. And so you don't really need 5,000 today or 10,000 today or 20,000 today because you know your money can grow. So what payment do you need so that with interest and everything else, it grows into that amount? All right, I'm going to pause it here and I'm going to do a couple examples for you. Okay, here are the two formulas we're talking about. And in my email, I said time is on your side. Okay, so we're going to use this formula first. All right, say that you can only scrape together $100 a month, okay? And again, sometimes people are like, well, it's not enough. I'm just not going to do it. Every little bit helps when we're talking about retirement. All right, say you can get 8% compounded monthly. And say you're going to make monthly payments. So those are going to match. Like if it's compounded monthly, you're going to make payments monthly. So you're going to make this per month and per month. And let's see what else. Say you can get 8% and okay, say you're 22 years old right now. And I know some of you are closer to my age, but that's okay. So say you're 22 years old and you're going to work till you're 65 years old. All right, that's your goal, is to retire at 65. All right, so that means you're going to work for what, 43 years? So that's your time. Okay, so if we look at our variables, your payment is what you're doing every month. So this is your payment, is right there. Now your interest rate, the decimal's at the end of the number, you have to move it 2 jumps you can never put a percent in a formula. You got to move the decimal. All right, so that's my rate. So R equals this, and I know time. Compounded is N. How often it's compounded? It's compounded monthly. So meaning you get interest every month. So there we go. All right. So now we know our variables. We are going to use this formula because we know our payment. We're not trying to figure it out. We know our payment. And it's not for a house or a car. It is for retirement. All right. So I'm going to put my payment in, double parentheses, and then I have 1 plus interest rate is 0.08 with the decimal moved. It is monthly. And this is where I'm like, I would always multiply these myself. Otherwise, you need another set of parentheses. So n times t. So what is it? Time is 43 years, 12. So I'm going to take my calculator. I'm going to take 43 times 12. And I get an exponent of 516 minus 1. And again, end of parentheses. And then our bottom, I need in my denominator, rate is 0.08. And again, n is how it's compounded, which is 12. All right. And if you have a good calculator, you should be able to type that all in at once. Okay, so type this in divided by that, as long as that's in parentheses. But if you're afraid it's not going to work, what I would advise is getting an answer on top, getting an answer on bottom, and divide. And again, do not round anything. So I'm going to do 100, and I'm going to do double parentheses, 1 plus 0.08 divided by 12. And this is my exponent key right there, exponent 516 minus 1 end of parentheses. All right, so I get 298.3295368, and I'm not going to round any of that. There was a lawsuit with Wells Fargo here in Des Moines. Okay, I took the 0.08 divided by 12, and they used Excel to do some mortgage work. And the way Excel rounded was actually off. So people's statements were off, and it might have only been off pennies, but it doesn't matter when you're dealing with money. And huge lawsuit, $millions of dollars. You can look it up, but it was due to using Excel and how Excel rounds. So again, in math, when you're dealing with money, you do not round till the end. Actually, in anything, you don't round till the end. All right, so I'm going to, again, type in every digit, okay, like every single one. All right, and so I get that. And again, I am not shocked. You might be shocked, but I am not shocked with how big that number is because I know how this works, okay? You will have almost $500,000, okay? Not quite, closer to $450,000. Okay, it might have glitched weird here, but again, in exponential growth, at first it looks linear, but it takes off later. And so you guys have time on your hand. Like after 10 years, it doesn't look much. 30 doesn't look much. You know, whatever, or 20 and then 30. But man, when you get to 40 years, it's a lot. All right, now, there is no formula for interest on things that are compounded. Only simple interest, which again, we tend to only use on a month-to-month basis with payments. But so here, what are your contributions, okay? So your contributions are what you pay. Well, it's your payment, right, money-wise. It's how often, which in this case, you did it monthly, so 12 months. And then you did it for how much time? Okay, well, you did it for what? 43, oopsie, not 45, 43 years, okay? So if you multiply those, right? So if I take our payment, okay, which was just $100 is all, times 12 months, times what, 43 years. All right, you contributed only $51,600 of that money. Everything else is interest. So to get your interest on a compound thing, compound interest, there's no formula. You take, you know, the money with interest, right? So you get the kind of the future value, which again is A, minus, you know, your contributions, what you paid. Okay, and again, you paid with payments. That's why we had to figure it out. You didn't just do a lump sum. So if I take 447, what is that? 494.31 minus the 51,600 you contributed. Everything else, so 395,894.31, all of that is interest that you earned, okay? That's money you earned. All right. So say that I'm like, okay, well, I want, you know, kind of what you have, right? I want to get up to this dollar amount. And so I want to figure out what payment I need to match you, okay? Which would be really nice, except the problem is I'm not young. Okay, I am 54 years old, okay? And say I want to retire at 64, okay? Maybe sooner, depends on the economy here. So I only have 10 years to invest. You had what, 43? I only have 10. There's no way a $100 payment is going to do this. I'm going to do 8% again, compounded monthly. And again, we're assuming it's in the stock market, right? Not just in a bank. And let's see what else. So compounding, let's see, monthly. So that'd be 0.08 when you move the decimal. Okay. And so that's my rate. My time is up here. I only have that much time. And then compounding is, again, it's still compounding monthly. All right. But we're going to use this formula because I want to, again, figure out what my payment is to match you. So, and again, if you want to put an extra parenthesis, if you're doing it all in one swoop on a calculator, that would probably be a good idea. All right. So amount, what is your amount? You had 447,494.31. That's how much money you had. And the interest rate is 8% and it's compounded monthly. Okay, so all I did is I put in the money that would be in the future, interest rate, and divide by compounding. Now I'm going to do the bottom, double parenthesis, 1.08 divided by 12. Now again, n times t. Now notice n times t for me, 10 years times that is only 120. My exponent is a lot smaller than yours, which is the problem because I don't benefit from exponential growth. All right, so all I did is the amount in the future with interest, okay, that 450-ish thousand-ish, rate in divided by how compounding, and then all of this. All right, so I'm going to type this in. Again, if you're going to do it in one swoop, I probably would recommend adding an extra parenthesis to that, okay? All right, so if you're not sure, I would say type in 494.31.08 divided by 12. Just to be safe, I would do the two parts. And then double parentheses. Oh, shoot, I cleared my calculator. I shouldn't have done that. Just typing it in. And again, my exponent key looks like that. Some exponent keys are different. Okay, so 1.219640235. And again, I'm not rounding. And then I'm going to divide those. And I cleared my calculator, so I can't just use second answer to help myself out. 1.219640235. All right. And this is sad. Okay. So basically what this is saying is me, would have to invest almost $2,500 every single month to equal. Okay, if it got a little glitchy there, I apologize. But again, if it's me waiting till I'm, 54 years old to start saving, and to be honest, I can't afford that. All right, there is no way. Like every single month, like this is like, yeah, horrid. I could not afford this. All right. Versus you, which again, some of you might not, you might not be here either where you can afford that. But notice if you do this starting at 22 years old, you can keep going. And what you could do is maybe you start out with $25 or $50 a month. You give up any habits that you have, expensive hobbies you have, you just try. And I mean, you need to live life too, but try to balance what you have and what you don't have. And I apologize, I've been digging in the garden, so my hands are kind of dirty. It's just dirt, good old garden dirt. But again, think about where you can make cuts. And maybe you can't right now, but maybe you can start when you're, 24 years old, or maybe you can start when you're 29 years old. You don't have as many years, so then you might have to up the money. And the other thing is maybe you start with $25 and then $50 and then $100 and then maybe $300 a month or $400 a month as you make more money. Okay. And again, it is a sacrifice. Saving is never easy. It's a little painful. Okay. For most of us. But again, look at the difference, right? If you're young, you got to start investing in the stock market. And again, yeah, it's risky, but overall, over time, it does pretty well. But you know what? Not saving is risky too. So I always view it as paper money. If it exists when I retire, great. If it doesn't, you know what? It's all okay. So, but I think I have to do something for the future. And I certainly know I can't do this. So I tried to start young. I wasn't always perfect myself because I stayed home for, 10 years with kids. And during that time, we didn't save much because we didn't have a lot of money. And I worked part-time and, we didn't have a lot of funds. When I went back to work, we were able to save more money. But again, I was older by then too. So, we'd have to make the best decisions we can. But I do want you to see that, hey, if you can start young, it is way less money because you have a lot more time. And if you wait till you're old enough, the problem is if you wait till you have money, you're too old and you wouldn't have that much money. So you got to find a way to try to save when you're younger. And again, invest in the stock market. And I don't do it myself. I hire someone because I don't know anything about the stock market. So I trust my Edward Jones person. All right.